Okay, laser's on. Sensor's on there. And this is working a lot better. There's a lot less vibration. You can see over here, like it's not even really moving. Here's how it looks like. And I've added some more tape just to, the non-shrink grout is stopped expanding. And that's just the wood layer right there. How you guys doing? So I finally had some time to get back into the garage, and I'm now about to start deforming the top and the bottom to get them nice and flat, nice and straight, because in this whole setup I can only really go straight, being like a one-dimensional line. So I put the laser, I don't have the original other setup. I'm going to use a laser level. It's going to work fine in this case because I have it clamped to the table, and it's also closer, so any deviation and wobble, let me turn this thing on. There we go. So any deviation will be a lot less just because everything's a lot closer instead of over here. When I had it on the chair over here, this whole table wobbles like a lot, and it's currently daylight. Like people in the house and the house across beside me, all that vibration is just, it's too much for the system. With this setup, it works pretty good. So that's what it looks like. And what I've done is just started all these threads because I'm going to be filling in the center between the two steel tubes with grout. And what I'll be doing is putting all these bolts in. So you can see the first one there. It's too dark in that tube, but you won't be able to see. But yeah, the bolts go in, and then they're going to press on the inside tube, and then I can tighten them as I'm taking the measurements with the tool over there, and then I can get everything straight, and then I pour grout in. If I can find my finger, so the grout will go in there, and that'll freeze everything in place, hopefully. I'll have to do the other side. I'll have to flip this thing around upside down so I can do the other side. And what I'll do is once I pour it in, I will vibrate it, and I think I have a hammer. Yeah, so I got a hammer drill right there. And what I'll probably do, let's see here. Well, I have a chunk of steel, and I'll just put that in the hammer drill and probably put a steel plate on the side of this thing, and then I can just jar into it and shake the hell out of it, and then that should get all the air bubbles out. Once that's all done, then I will just put it horizontally so the weight of the grout won't be deforming the tube as much, because I'll just put it horizontal. Okay, so all the bolts are in, and I have marked the holes, and I'll be running the sensor between them, like so. And from the previous video, or 2 videos ago, I believe it was point number 3, had a big dip in it, so it'll be interesting to see if I get that as well. I have greased all the threads here because I have to pull them out of concrete or grout, and I don't want them to be permanently stuck in there. Okay, laser's on. Sensor's on there. And this is working a lot better. There's a lot less vibration. You can see over here, like it's not even really moving. So it's around, I don't know, it's hard to say, 10 microns or so, maybe maximum, maybe less. Yeah, so I just gotta watch out, because any kind of movement on the table, like that's quite a bit actually. Yeah, so I just have to watch out for that. But I think this way works pretty good, especially if you're going to use like a self-leveling laser. I was going to run the point laser, the one that I took out. I took out the bottom one here. You can see there's no reflector. But yeah, I'm going to just run the self-leveling laser. Like, I don't need extreme accuracy for what I'm doing. I am going to run, after the grout has been done, I'm going to do a second pass with a epoxy, possibly self-blowing epoxy. I have a big 6-inch level, and I don't know how straight it is, but what I'll do is I'll measure that thing, and if that thing is flatter than this whole setup after the grout's poured in, I might transfer through epoxy, like replicate the surface of that just along the center, and I think that might work out really well. Another thing I'll point out is because the laser and the sensor are so close to each other, the auto exposure on the webcam sensor, like it's having a hard time trying to deal with the noise from the laser. You can see how the pattern changes. So what I might do is crank up the smoothness really high, because that seems to do a much better job of just kind of centering on this big mess, and that shouldn't really matter so much when I go over there. So if I put it further along, I turn the smoothing off and not touch the table. So that's kind of what it looks like. The previous setup I had, I could control the voltage on the laser diode, and yeah, if you're going to be doing a setup, that would be much better, because if you're doing it like this, then you can kind of limit the brightness of everything and not have to rely on the sensor. This is a good reason to make your own setup, your own laser emitter, is that way you can control the voltage of the laser, and then you won't have this kind of stuff, because this is just because like that beam is so bright over there, and the sensor is just trying to expose it down a lot, and it's just producing tons of noise. Alright, here's my results after 20 samples. So I've marked them all. And yeah, on the flattened version, which uses linear regression to get rid of the slope, it looks like that. So there's a big dip there, and it is like there is a dip there as well, and that's I think 0.3. I think, yeah, that's 0.3, and that coincides with the previous video where it was this one where there was a big change. And the rail from the previous video, with using the hard drive spinning to make a flat line, I found that polishing aluminum to be optical quality is kind of impossible, or at least for like a home guy in a garage. And like if you search online, you'll see stuff like using India ink as a final pass of polishing, and I tried India ink as well, but I don't know, maybe the stuff I used a very fine diamond polishing compound. It was used for like rock tumbling, and that stuff, yeah, like aluminum is just so soft. It's just, yeah, I don't know how you're supposed to do it. Right? And also, like, aluminum is gonna oxides almost instantly, so your reflective mirror is gonna be tarnished and stuff pretty quick. So one thing I like to add to the tool is to measure the slope, so the local slope on like this surface, and that's effectively like this value. So you can see how much that would affect that. And what I would do is take the webcam sensor, and I actually ordered another one of these webcams, and point it the other way so it's on the back side. Like, I'll make a different kind of mount and everything, and what I'll use is a mirror to bounce the laser coming off back onto this side. And I thought about like a steel shaft, like this is some kind of stainless steel shaft, something like this, like a little chunk of it, maybe a centimeter, an inch or so, and have it like 6 inches from the first sensor. And that would give me a total of, as the mirror is bouncing that way and then back, that would give me a foot of area where I could measure the slope between the two of them, and that should give me the local slope. And then in the tool, I would have like the position, like the sensor feed and the analyzer have the position up here and then basically just make this, because these two things run in their own thread, and I could run a second one and it wouldn't like increase the processing power like of the tool, and I would have them both there. And then by checking the difference of the 0 point between both sensors, I could determine the local slope of that area, and then like that would just get you an ability to get these values of that the slope error, you could account for that. So with these measurements, I'm going to go through and start replacing samples of these, and I'll just tighten them. Let me just try, for example, on 0.3 it is. Yeah, so right there. So let's just see. I've never tried this, so let's see if this actually works. So if I replace the sample, it should be somewhere there still. And I don't know if it moved. Yeah, it is. It's just moving by like a micron. Okay, so I don't know if I need to move it up or down. I should have put a little bit of tension on all of them, but okay, let's just do that much. See what that does. Yeah, so that brings it up. So I'll move the other one too. It's really cumbersome doing this with one hand, trying to do everything through a camera. Okay, that should bring it up a lot. Yeah, so that's down to negative 25 microns. So yeah, that actually seems to be working. So I'll bring the next one up, because that one, I think what you do is you just hit all the highest points like I'm doing, and then you, like, as you're doing this, like I'm tightening this one, but I'm changing this one, I'm probably changing this one, possibly that one. Like I'm changing a range as I'm tightening everything. So like doing probably an iterative pass of doing a bunch and then going back, and then to take the final measurement, you have to just go over everything all over again. Actually, I gotta change the this one is actually 4. Yeah, that's 4. So I need to replace sample 4. Yeah, that moved it up a lot. So I will back this one off. See if it goes back down a bit. Yeah. Okay, well I'll get this one number 3 up, and then I'm gonna go and put a little bit of tension on all of them, because right now like they don't have any tension, and it's probably better to get them all slightly tensioned, just because that way, like when the grout is in there, it's kind of got a bit of preload on it, and it's less likely to move. Okay, so I have a bunch of preload on all the bolts, so instead of trying to record all the stuff, I'll go through and try and do a first pass, and then I'll show you the results after that. Alright, I've gone through numerous times now, and here's the flattened version. So yeah, the ends, I can't obviously push them up because there's just not a bolt there, so they dip down. This is a lot like truing a bicycle wheel. Like if you think about these as spokes, it is a lot harder than I thought it'd be, because like, for instance, this is 0.12, I think. Yeah, that's 0.12 right there. But like if I'm tightening on this side here, it is having an effect there. So I don't think this method that I'm trying to do is going to work all that well, especially because once I'm tightening the bottom side, like I'm going to screw up the other side. So it's not like I can get them, you know, done in isolation from each other. And like it seems like this whole beam has like a kind of a high spot here, and then there is a low spot, a localized low spot, and then it kind of bumps up again. But like if I'm like tightening these up to compensate for that high spot, and tightening these up, and you know, tightening the ends more than here, right? Like if you think of like a gradient, like it's still pushing that one up quite a lot, and it's overall it's not really changing the shape at all. All it's doing is really like it's pushing everything up, but it's not, you know, like I still have the problem of the ends on both sides, and you can see that there. And then like this is where that kind of like messed up area is, and like I don't have the resolution to like kind of raise one without raising the other one beside it. If I had a setup where I could measure off of something like that, but even that's kind of, you know, that's kind of difficult. So what I think I'll do is I might try and see, I might even loosen everything again and just get everything back to how it was originally, and just see if I can figure out how to get just this area a little better, and yeah, then pour the grout, because like this is going to be a problem that I'll have to fix with epoxy, and if I'm doing that by that much, then you know the area in the center here should be easy as well. So I've loosened all the bolts off on that side, and what I'll do is when I'm done the grouting of this, then I'll go and do this with epoxy, because like tightening the bolts is just not working. And so what I've done is gone ahead and done all the bolts, filled them all in, and fortunately this one here on the very end, because I had that chunk of steel there welded, it's I don't know if this will pick up on camera. Nope. Well, the that intersects with that bolt, so I don't have any. I have nothing but the threads, and this holds the end of the rail on the BF block side. The BK block is on that side with the servo and everything. So it's not really that big of a deal, I don't think. I do have a bit of thread there, but I'll probably just have to finesse one, like the bolt that goes in there, and just cut it so it just picks up the thread, and just deal with that way. So I need to finish up on some of these holes. I'll just have to plug them, like this one here. I don't need that hole anymore, so I just need to probably just put some tape on it and let the concrete fill in. And same with these ones here. There's 4 of them there. Don't need those. So I'll do that, and then I need to make one side the top and one side the bottom. Servo goes here, so I'll probably make this the top, and I'll need to make a plug to fill in the inside here. And then on the bottom, I need to plug this whole thing. So I need to plug like a plug the width of this that can slide all the way in, and then go up here, seal all that in. Alright, so I made a plug for the bottom here, and this is just gonna go in like this, and then I'll hammer it in. And what I'll do is put a bead of hot glue around it, so that way it'll hopefully seal this up a little better. And then where it's welded, some of it protrudes out a bit, but this is like soft, really old pine, so I think if I just hammer it in, I'll be able to just mash it in so it'll butt up against this inside tube and then create a seal. I don't need a perfect seal for this thing, because the grout, it's gonna get to an edge and then it's gonna fill it up really quickly and solidify. And the saran wrap just helps, so when I want to take it out, it will come out and not be all glued in there. And here's the top plug. So this one's gonna go on the inside, just like that. This just stops the grout from making its way in the center, and it'll flow naturally down the sides. Alright, so it's all done now. Some tape to clean up, fill out the holes, and then I put this foot on, and that just has something for it to rest on and put pressure onto the one that's been fit in there. And then same for this side. So this is the top where it goes in. This one has been hammered in, and then I'll just drill it out and bang it out later. And then some more tape just to fill in some of the holes. Here's how it looks like. And I've added some more tape just to handle the spill. And on the hammer drill, I have a little chunk of steel in there, and I'm going to use that against these chunks of steel to vibrate all of the bubbles out. And with that, I'm ready to pour. Alright, so it's poured now, and I poured it in one go. It was a lot easier than I thought it'd be. I thought I would have issues with it, like getting stuck on the, and filling up because it's really thin. But yeah, I poured it in one go, and it didn't even really overflow much. And then after it was done, I used the hammer drill, and that worked pretty good. So this is a good way to do it. Your clamps are going to fall off, so you just got to get them nice and tight. And I should probably just back these off, so you can see, like, yeah, you know when it's working because you see all the bubbles coming up, and you just keep on going until there's no more bubbles. So I've scraped off I don't know, maybe half a centimeter or so at the top, and then I'll just let this solidify, and then I can smash this thing out. Here is the grout I'm using, for those that want to know. Ultimately, using the laser to deform the surface didn't really work out, but that's okay, because once this is dried, then I can go over and use it again on a different method. Alright, so it's been 2 hours, and the non-shrink grout is stopped expanding, and that's just the wood layer right there. And yeah, clamps off. This one's just very loose, so it's not squishing anything. And a little bit of water coming out the bottom, which is kind of expected, but yeah, it's not that bad. No grouts coming out. And yeah, this all looks good here. I have some tape holding the bottom there, so I put a bit of electrical tape on it just to hold back the hydraulic pressure, and yeah, same on the top. So yeah, I think I'll let this thing sit and call this a video, and I will see you guys in the next one.